Hello friends, how are you all doing? So in this video we will start with this particular equation in question number 7 of exercise 5D. So friends, if you look at this equation, it doesn't appear to be a quadratic equation at all. There is a square root sign. So how do we approach this particular problem? So if you observe, this is x upon x minus 3 and this is x minus 3 upon x. So they are totally reciprocals of each other. And there is a square root also in both these terms. So what we can do is, we can substitute this big value with a single value so that it is easy for us to solve this equation. So what we will do is, we will say, let root of x upon x minus 3 be y. You can take this particular term also as y. It is totally up to you. So when I take this particular term as y, what will happen? I have to substitute this particular value also in terms of y. So friends, what we do is we split the square root here. We'll get root x upon root of x minus 3 as y. Now somehow I have to get this particular term using this term, which is very easy enough, I'm sure. You just do cross multiplication. So what you will get is 1 upon y, this comes down, is equal to, this goes up. So this is what we get, which means 1 upon y is nothing but square root of x minus 3 upon x, which is nothing but your second term. So we have been able to express both these terms in terms of y. One term is y, the other term is 1 upon y. So now what we can do is, we can substitute. Say if I call this equation as 1 and this equation as 2 and 3, you have to substitute equation 2 and 3 in the first equation. So when you do that, what will happen? We'll get y plus 1 upon y is equal to 5 upon 2. Now this is so simple compared to this particular equation, is it not? Now if you see, we can take the LCM. We'll get y square plus 1 equal to 5 by 2. Now what happens next? I'm sure you know that we have to do the cross multiplication. So let's do that, which implies you will get, let's open up the brackets. See, this is so simple compared to the question. Okay, so this is the power of substitution, friends. Now this equation is a very simple, nice quadratic equation in y. I'm sure you'll be able to factorize it, and I'm sure you must have guessed the factors also. So it's 2y square minus 4y minus y plus 2, is equal to 0. So let's do the factorization. So this is how you do it. This is because of factorization and because of the zero product rule. See, we have got the values of y also because of the zero product rule. So friends, 2y minus 1 is 0 or y minus 2 is 0, which implies y is how much? Half, correct. Or y is equal to 2. So these are the two values. But has your answer been achieved? Not at all. We have to find the value of x, which means I have to substitute one by one the value of y in any equation you can take. See, either you can take equation number 2 or you can take equation number 3. It's totally up to you. So I'll just substitute in equation number 2, which is root of x upon x minus 3 is equal to y, which is half. So now what do we do? I'm sure you know the next step. You just have to take square on both the sides. So taking squares on both sides, what do we get? If you want, I'll write the intermediate step also. Just take the square like this. So the next step is the square root nullifies with the square. So you will get x upon x minus 3 equal to 1 by 4. Cross multiplication follows. Okay, 3x is minus 3, which implies x is minus 1. We got a nice value of x for y equal to half. Now let's again continue. We have to substitute one more value of y, is it not? We have to take y equal to 2 and put it in equation 2. So we'll get root of x upon x minus 3 is equal to 2. Take squares on both sides. You will get x upon x minus 3 equal to 4, which means, let's cross multiply now. You'll get x as 4x minus 12, which implies minus 3x is minus 12. So what is the answer? Have you guessed it? Yes, x is 4. So here we are with two values of x. So definitely this was a quadratic equation only because we got two values of x. So x is equal to minus 1 or x is equal to 4. This is the final answer.